Namaskar friends, I welcome you all in this class of mathematics. So in the last class we discussed about limits and how to take limit of a function. Now we had learned last time some standard results that in case of failure of direct substitution method DSM, what should we do, and we learned several techniques, and we also saw some standard results for taking limits to be used, but we did not solve example on that. We will solve example later on, but today I will give you the concept of infinite limit and then right hand and left hand limits. So once this is clear, then we will solve various examples so that the method will be clear to you. So concept of infinite limit first. Okay. Let us consider limit of sequence. You know what is sequence? We have learnt earlier. So suppose this is a sequence 1, 2, 3, 4, 5. So where is this sequence leading? This is leading to, I think, infinity. Now another sequence 1 by 2, 2 by 3, 3 by 4, 4 by 5, and so on. Now you can see that this sequence is leading to some finite value. So if I go further in this sequence and if I take the 3 decimal digit, so its value will come like 0.888, then 0.9, 0.909, and so on. So because you see in this sequence term 999 upon 1000 increasing like this will also come. So it is equal to 0.999. So this sequence is approaching towards 1, but it is not exactly 1. So if I take 1 minus 0.999, it will be 0.001. So as I go on increasing the nth term as n increases, you will see that this difference will become lower, and the value of Sn will become more and more nearer to 1. So this is the concept of limit, that we say that as n tends to infinite, the xn will tend to some finite value, and that is called its limit. Now let us see some different type of sequence. So there are sequence which increase or decrease indefinitely. Increase or decrease say this is a sequence, say zero, -1, -3, -8. So this sequence is decreasing and it will reach to -infinity. Another sequence 1, 5, 10, 17, 26 and so on. So it will reach to +infinity. Now there are sequences which increase or decrease at decreasing rate. Say 1, 1/2, 1/3, 1/4 and so on. So you see this sequence is going towards not exactly 0 but towards 0. Again another sequence you take 1/2, 2/3 as we checked earlier, 3/4, 4/5 and so on. So this is approaching towards 1. Now there are many other type of sequence, maybe third type, fluctuating. Okay, and with wider margin. So that we cannot conclude anything. Maybe 1, 5, -7, 17, -31 and so on. There may be sequences which have no tendency to increase or decrease. Such that -1, 1, again -1, 1, minus 1, 1, either neither increasing nor decreasing. There may be sequence which fluctuate with decreasing margin. They fluctuate. We have seen wider margin. Here it is decreasing margin. So it may be minus 1 by 2, then plus 1 by 4, then minus 1 by 8, then plus 1 by 16, and so on. So they will reach to some finite value. You see, if I draw graph, this is x-axis, this is y-axis. So as x is increasing, the fx is so the fluctuation will go on decreasing, you see. So at least it is leading to some particular value around which it is fluctuating. So what we conclude from this? We conclude that we can categorize them in basically 3 types of sequence. Number 1, they are leading towards infinity, either plus infinity or minus infinity. Then the other sequences are which are leading towards some finite value. Okay, and there are third category of sequence which are leading nowhere. Nowhere. So what is important here? The second one, those sequences which are leading towards some finite value. So that is important. We can say that it has a limiting value, and we define it, limit, as n tends to infinity. The value of x10 is equal to some value L, and we call it tends to L. Now this is not the complete definition according to mathematics. So let us define the complete mathematical definition. So when a function or a sequence has a limit, if there is the sequence is converging, it means that as n is increasing, the sequence goes to a limiting value as xn, as n tends to, at is good, it is not infinity, at is goes nearer and nearer to infinity, it becomes larger and larger, then the value of xn, it becomes nearer and nearer to L. So suppose if epsilon there exists and epsilon greater than equal to 0, a very small quantity, very small number, very small. So in that case, the error, that is xn minus L, let us take mod, that whether difference between xn and L will be less than equal to epsilon. Now epsilon is a Greek word, and it is defined in mathematics in such a way that it is a small quantity. So howsoever small we can choose, 0.01, 0.001, 0.401, howsoever we can choose small epsilon, this identity should satisfy, whereas there is a number n which is greater than 1, and for all values n greater than equal to n, the value of xn minus L difference will be less than equal to epsilon. So once this is satisfied, then we call it as limit of xn as n tends to infinity is equal to L, because as n increases, you just understand it that as n increases, a series is there, 1 by 2, 2 by 3, 3 by 4, and so on. So as n increasing, the nth term, the difference between xn minus L is going to decrease. So here L is 1 here, because it is approaching towards 1. So as it go on increasing, difference between the nth term and the L, that is the limiting value, difference is coming smaller and smaller, and we can take whatever small value epsilon, only thing that accordingly n will be adjusted, n will increase. So after so many terms, a situation will come that after that value of n, whatever xn we will take, the difference between xn minus L will be less than equal to epsilon. So this is the proper definition of the limit. Now let us understand the left hand and right hand limit. You see, this is real number line, okay, and say x is equal to a is this point. Left hand limit means that we can approach towards a either from left or from right. So this is x, this is y axis. This is y axis. So as the x approaches towards a, if a function is there, what value y will approach? It means fx will approach. So that will be the limiting value for that function. You have understood about this limiting value for sequence. Now let us apply it for a function. Say y is equal to fx. So similarly we define that limit when x tends to a, value of fx is equal to L So as x tends to a, approaches a, the value of fx will be equal to L if the value of fx minus L is less than equal to epsilon and n is greater than 1. So for all n greater than equal to n, the value of fx minus L will be less than equal to epsilon. So as x tends to a means that you are going from this side. Say I say limit x tends to a minus. A minus means you are approaching a from left. Then what will be the value of y? Let us say is equal to L1. And if you are approaching A from right side, what will be the value of Fx, where it will tend to, let us say, L2. So you see in this figure, we are approaching from this side, it is A minus, and we are approaching from this side, it is A plus. And say some function is there, so this is the value of y, that Fx, say L is there. So either coming from this side or this side, the value is approaching L, and it is coming nearer and nearer as x approaches nearer and nearer to A plus or A minus. So we say that limit exists only when left hand limit is equal to right hand limit. It means when L1 is equal to L2, in that case, say it is equal to L, so limit exists and is equal to L. But if left hand limit and right hand limit are not equal, it means L1 is not equal to L2, then this means that limit doesn't exist. Let us take some example. Say this is x and this is function y is equal to fx, and this is our function. So at some point at x is equal to a, the value of y is equal to, say, L. So as we approach from left, say from this side, it is going to be here. So left, I mean A minus. And as we approach from right, from this side, as we are coming, A is coming nearer, x is coming nearer to A, the value of this y is also coming nearer to A, to L. earlier it was coming nearer to L from this side. So, and both are converging at a point L. So here we say that L left hand limit is equal to right hand limit, and so the limit exists. Let us take another example of function where this is x and this is y. So this is a step function. Say this is x is equal to a, and so function may be fx is equal to say 2 and 4 when x is greater than a and maybe greater than equal to a, and x is less than a, then x is equal to y is equal to fx is equal to 4. So this is the graphical presentation. Here this point is not there, so we will, this point is included here. So as you can see, say this is value L1 and this is L2. So when we take limit x a minus when it is approaching from left, x is approaching from this side. So left means that it has a value 4 when x is less than a. Its value is 4. So fx is equal to 4, and when x approaches from right, fx is equal to 2. So this is equal to L1. Let us say this equals to L2. So you can see that L1 is not equal to L2. So the limit does not exist in this case. Now let us take another example. Say x is equal to a, this is x-axis, this is y-axis, this is L. So here you can see that when x is approaching a from left, from this side, it is approaching towards L, fx is approaching towards L, and when x is approaching towards A from right side, it is also approaching towards L. So x tends to A minus, this is left side, it is equal to L, and if it approaches from the right side, from this side, the value of fx approaches towards the same value L. So it is, both are equal. So in this case, limit exists and this is equal to L. So you can see several examples. Let us take one more example. There may be hyperbolic function, the value of a, and this is L. Now here the function shows it is a hyperbolic function. So as limit of function as x approaches a minus from left side, fx is equal to, this is y. So it is not you see, when x is approaching towards A, y is approaching to minus infinity. It is not converging. And when x tends to A plus from right side, its value is approaching towards plus infinity. So if you come from this side, this value will reach to plus infinity, whereas if you are coming from this side, this is going to reach minus infinity. So in this case, limit doesn't exist. Now we will take some more example that how we use algebra to solve problems of limits. Suppose limit x tends to 3, x minus 3. We have to find it out. Now let us take left hand limit. Okay, so x is approaching from left, that is 3 minus. So in that case we can take x is equal to, it is not equal to 3 but it is 3 slightly less than 3 minus h, where h is a small quantity, h is greater than 0, small. So as x approaches 3 minus, h approaches 0 plus. What does it mean? It means that as x is approaching 3 from left side, the value of h is decreasing from right side. I mean it is becoming smaller and smaller because h is already greater than 0, so it will become a smaller interval, but it will never be equal to 0. So then we can write limit h tends to 0 plus. The same limit we can write like this, and in place of x we can write 3 minus h minus 3 mod, which will be equal to limit h tends to 0 plus, and this will be equal to, this 3 and 3 will be cancelled out, so it will be minus h mod, which will be equal to limit h tends to 0 plus, this will be equal to h, which will be equal to 0. Now let us take right hand limit, in which x will approaches 3 from the right side, 3 plus. So let us take h such that x is equal to 3 plus h. Here x is approaching from right side. You see in this number line, x is approaching, this is 3, value of 3 from the right side. So we are taking h a small quantity, so as h is becoming smaller and smaller as x approaches towards 3. So this will be equal to limit h tends to 0 plus mod of, in place of x we write 3 plus h the function is x minus 3, so 3 plus h minus 3, which will be equal to limit h tends to 0 plus, and these will be cancelled out, so it will be mod h, so which will be equal to limit h tends to 0 plus will be equal to h, so which will be equal to 0. So here we can see that left hand limit and right hand limit are equal, which are equal to 0, so limit exists. Now let us take another example. Say limit x tends to 0 5x plus mod x divided by 3 mod x minus 7x. Three mod x minus 7x. Now quickly you have understood the concept, so quickly we will do it. Let us take from the left side that x is equal to 0 minus h. Okay, so as x tends to 0, h tends to 0 plus. So it will be limit x tends to 0 minus 5x. So it will be 5 and x is equal to 0 minus h plus mod x mod 0 minus h divided by 3 mod 0 minus h minus 7 0 minus h. So it will be equal to limit h tends to 0 plus, and this will be minus 5h plus mod of minus h will be plus h divided by mod of minus h will be plus h here, so it will be 3h here minus minus plus, so this will become plus 7h. So this is equal to limit h tends to 0 plus, and this will be minus 4h divided by 10h. So h will be cancelled out, so we put h is equal to 0. We don't need to put because h has been cancelled out, so it will be equal to minus 4 upon 10, which is equal to minus 2 upon 5. So this is left hand limit. Let us take right hand limit. In that case we will take x, because we are approaching x from the right side, so x will be equal to 0 plus h, 0 plus h. So let us take the function limit h tends to 0 plus and 5x plus mod x, so 5 0 plus h plus mod 0 plus h divided by 3 mod 0 plus h minus 7x minus 7 0 plus h. So this will be equal to 5h plus h divided by 3h minus 7h. So So this will be finally equal to 6h divided by minus 4h. H will be cancelled out and it will be equal to minus 3 by 2. So friends, you can see here that LHL is not equal to RHL. LHL was minus 2 by 5 and here minus 3 by 2. So these are not equal. So limit doesn't exist. So I hope you have understood the concept of limit. In the next class we will do some more examples, and we will also use some standard results. So next class we will do only examples so that it will clarify your doubts. Thank you very much.